This is for question 8 in chapter 3. It says a remote control car is moving in a vacant parking lot. The velocity of the car as a function of time is given as v vector equals 5 meters per second minus 0.0180 meters per second cubed times t squared in the I direction plus 2 meters per second plus 0.550 meters per second squared times t in the j direction. So what I have written right here, it asks what are ax in relation to time or acceleration in the x direction in relation to time, and acceleration y in the relation to time, and x and y components of the car's velocity as functions of time. So the first thing we're going to do is we're going to split this up into the I and j portions. So we'll say the I, since it's the x direction, will be vx, and we can take that by itself. So 5.00 meters per second minus 0.0180 meters per second squared times t squared, and that is the I hat. And then if we want to get the acceleration from the velocity, we just take the derivative. So if we take the derivative of this 5 goes to 0, so then we're left with 2 times 0.0180 meters per second times t. Meters squared times t, and then we multiply this out, and I forgot this is negative right here. Oops, this goes in the front, so that will give us negative 0.036 t meters per second squared. And now for the j direction, I'll just change this to I and j. Same idea. Meters per second plus 0.550 meters per second squared times t, all to j hat. Take the derivative of this, and this goes to 0, and we get 0.550 meters per second t. So that's for part A. So for part B, we're gonna use a different, let's say for part B. Part B, what are the magnitude and direction of the car's velocity at time equals 8 seconds? So now we're gonna use the same idea, but we're gonna plug in 8 seconds. So this is for part A. This will be for part B. If we draw it out, velocity will be right here. We'll have a theta, and we have to figure out the x and the y component for 8 seconds. So what we do is, it's an x. Take the 5 from up here, meters per second minus 0.0180 meters per second squared times, this is going to be the time that we're given, so 8 squared in the I direction, which when you multiply that out, it gives you 3.848 meters per second in the I direction, and this the y direction, which is just the j, you get the 2 meters per second plus 0.550 meters per second squared times the 8 seconds, write that there, in the j direction, and that'll equal 6.40 meters per second in the j direction. So now we have that, so 6.40 and 3.848. Now we can solve for this side for velocity and the angle. So we can put in tangent theta is equal to the opposite over adjacent, so 6.40 over 3.848. You manipulate that to get theta equals inverse tangent of 6.4 over 3.848, and that'll give you 58.9 degrees, or rounded up to 59 degrees. And then from there you take the Pythagorean theorem to find out this length in V. So that'll be, make sure we have room, V equals square root of 6.40 squared plus 3.848 squared, and that will give you 7.467, or rounded to 7.47 meters per second for this direction here at 59 degrees. So that is part B. Now I'm going to erase this for part C, or ask for the acceleration. Alright, for part C it asks, what are the magnitude and direction of the car's acceleration at 8 seconds? So for this one, we are, let's see, so we know from what I just erased, the y or x direction, or I, was negative 0.036 meters per second t, and the j direction was 0.550 meters per second squared. This was squared too. Alright, so if this is in the I direction and this is in the j direction, we know that we're gonna have something like this. Theta there, the I direction, this is negative 0.036 meters per second, and the j is 0.550 meters per second in the y direction, or j. So just like the last problem, this is going to be the acceleration, so we just need to take the tangent of this angle. So tangent theta equals the opposite over adjacent, so 0.550 over negative 0.036. manipulate that so you get inverse tangent 0.550 over negative 0.036, and you get 117.6 degrees for theta. Now to find this, you just use sine, because now you know the angle. So that'll be sine 117.6 degrees equals 0.550 over a vector, and then you just manipulate that again just to find a vector equals 0.550 over sine of 117.6, which equals 0.621 meters per second squared for the acceleration. And that is the last part of this problem.